Right, quick demo on the bgpls-broker. So let me just grab this. I'll just bring the neighborship down so we know what we're working with. But essentially this exposes BGP link state to the end user. I'll look at the BGP config and bring that down quickly, just so we have a fresh plate. 10.4.20, shut that down, commit that. Right, we have a database that's maintained, bgpls nodes, for example, that contains all the nodes on the network, all the link state nodes, such as ISIS nodes or SPF routers, SPF nodes. And then we have an endpoint that gets us the topology, which includes the nodes, but then it inherits the links and the prefixes that relate to that node through the bgpls identifier, which is just a it's a unique identifier for BGP link state. It's just a autonomous system and the router ID, which should always be unique, even if you have disjoint network with a unified MPLS. When you have something like unified MPLS, when you have multiple IGP domains, I've seen third parties a lot of the time they use BGP link state to expose the link state database to an application, and then the application can kind of work out things like a label switch path. It can build a label switch path based on the different IGP domains and the autonomous systems, and now no longer it is not disjoint. Although it is technically disjoint and the networks are not are in their own IGP domains, the application can kind of work out the whole topology, which is pretty cool. So let me just show you a log as well. We'll go and Docker compose logs, and we should see the link state database kind of start to be sent through BGP link state, and then I print out. For now, in the login, I just show you the all the updates that I received. So let me note out that neighbor. This might take some time. I might need to clear BGP just to speed it up a little bit. So the cool thing about this is that within the database, there's a database that stores or maintains the state of the network through these BGP link state updates. And when a neighborship goes down, it will flush the database. So here you can see that's looking nice and fresh. So all these link state updates are now came through with all this information regarding BGP-LS nodes, along with the information that's encoded, in that BGP update, such as MPLS traffic engineering attributes, segment routing attributes, as you can see here, different capabilities and segment identifiers, and SI algorithms for like flex algorithm, and you also have like BGPLS links and prefixes. So let me run this script. I just got a script to pull out the API. It just queries the API, which is that topology endpoint. So bgpls nodes will just show you the nodes, whereas get topology will get all the nodes, and then it'll get all the links and prefixes related to that specific node, which can be identified by if you get the links, like a link can be identified normally by the local node descriptor, which includes the autonomous system and the router ID, which should be, that should be enough information to identify that this link relates to this specific node. Okay, so I have a Python script that just prints out a table of the topology. So here we have links, between router 2 and router 5 we have a link, and then between router 1 and router 2 we have a link. Let's check that, router 2, that's correct. Router 2 is connected to router 1 and router 5. Let's bring down this link, and you'll see that the database is maintained, which then means that API is actually like a kind of active state of your network. It keeps in sync with your network based on the IGP changes, which are then reflected to this BGP link state listener, because he is also in the IGP here, and then he will distribute those changes into BGP link state table, and then those will be propagated to the BGP listener, which is on ExaBGP. It's running as a container. Let's look at the logs, and we'll show that change. So let's bring the link between router 2 and router 5. There we go, you'll see that change. It's occurred quite quickly. The IGP has converged. The IGP has sent out the, the link state update, or the update for ISIS, and that has propagated into BGP on the XRV1, which is 9K, XRV 9K. And you can see this is, said withdraw. So what's going to happen is the application that I wrote will actually maintain that state in the network. And you can see there's a withdrawal route as well from router 5, sorry. So router 5, obviously maybe the ISIS hold timer has expired because in EVE-NG it can't detect the link going down. So here we have, the prefix and the link that has been withdrawn from the table. So if we run that script again, that prints out our topology. We can see here this topology has been maintained. If I try to find 10.0. What do we do? 25. We see it twice. This is the old topology. So we see the interface address, which is on router 5, and then, or even if I show router 2, we only have 2 links technically, which is right, because 2 links make up an adjacency. Because we've got, the receiving neighbor, or should I say, X neighbor and A neighbor and B neighbor in our case. If I grab that again, there isn't any information because the link's down. However, the prefix is still available. That's probably because the ISIS adjacency on router 5 has gone down. However, the interface is still up and advertising to ISIS. Which you can see here, the node descriptor is the person that is sending that update, who can be identified in the actual link state database. Okay, so that's that, and then if we just do a quick change, this is the topology, what it looks like so far. So obviously, this is just me just wanting a really quick way of just showing you what the API can look like. Obviously, you can pull it from you can pull it into an API, like pull from the API into your own app and generate a graph. You can easily generate what the topology looks like. What the actual link state topology looks like, the ISIS topology, including all the traffic engineering attributes, which is the key important thing that's really cool about this. Is you've got those traffic engineering attributes and IGP metrics, traffic engineering metrics, segment routing flags, segment routing, unreserved bandwidth and all that fun stuff. And even the algorithms, for example, the flex algorithm. So that's all cool stuff. Let me run the logs again, do a no shut, and we'll see what happens. So that interface will come back up. There we go, the information is propagated very, very fast. And then we print our topology again. And there you go. You see XRV2 link and XRV5 has got a new link. That's because the database is maintained. And then we see on our topology we have no results for router 2. We get it again. We do have 2 results. One from the local neighbor, which is originating from router 2, and then one from router 5, which is neighbor address from router 5. And router 2, this is the local link that's related to router 2, XRV2, which is the node here. Okay, so that's fun stuff. Hopefully that's been cool. Done this under 10 minutes, so hopefully if anyone's interested, you can obviously go to, I'll leave a link as well to the bgpls-broker. But it's something that I really want to start working on a bit more and actually supporting, because I think it's an interesting project. Thanks a lot.